Okay, for a system of three equations and three variables, we want to solve in a similar fashion by getting rid of the variables one by one until we have a triangular shape. Let's look at an example. Okay, so this is our system of equations. We have three equations and three variables, x, y, and z. Notice this in the second equation, we have a negative x, and if we were to add that to the first equation, the x terms would cancel out. So let's do the first equation, add that to the second equation. Okay, the first equation just stays the same. Now we're going to replace that second equation by taking the result of adding the first equation to the second equation. So we'll get 0x plus 3y plus 4z. That third equation just stays the same, so let's rewrite it down here. Okay. Now let's try to get rid of this x term down here in that third equation by multiplying the first equation by minus 3. So that's going to be like this. Minus 3 times the first equation plus the third equation. Okay, so let's leave the first equation as it is. The second equation just stays the same. Now here we're going to get minus 3x plus 3x, so that's going to give you 0x. So we won't have an x term. We have minus 3y minus 3y, which is minus 6y, minus 3z plus z is minus 2z, and then minus 3 times 0, which is 0, minus 1, which is minus 1. Okay, so let's look at this down here, these two equations. Let's try to cancel the y term. Okay, we want this 3 here, the coefficient, to be 6, so that when we add it to the minus 6y, they'll cancel out. So let's multiply this second equation here by 2. Okay, so 2 times the second equation. Add that to the third equation. Okay, so alright. Let's rewrite the first equation. The second equation stays the same. And then here we get 6y minus 6y, which is 0y. 8z minus 2z, which is 6z. And then 2 minus 1, which is 1. Okay. So now, look down here at this 6z. We want the coefficient to be 1. So let's divide out by 6. So it's going to be 1/6 times the third equation. So let's rewrite everything here. And we get z equals to 1/6. Look at the coefficient of y in this second equation. We want that to be 1. So let's divide the second equation by 3. So 1/3 times the second equation. Okay, so now we have this set of equations. All the coefficients of these leading variables here are 1. Okay. Now, when you have this triangular shape here, we reduced it to this triangular shape. All the variables in the front have coefficient 1. Then we say that it's in row echelon form. Okay. Row echelon form. Okay, so that's this here. This triangular shape. If we can get the system of equations to look like this, and all the coefficients are 1, we say that it's in row echelon form. Alright, let's do another example. Let's say you had this set of equations. Okay, let's try to get rid of this x variable here by multiplying the first equation by -3. So -3 times the first equation and add that to the second equation. And what do we get? Okay, so leave the first equation as it is. Here we have minus 3x plus 3x, which is 0x. Here we have minus 3 times minus 2, which is 6. So we'll have 6y plus 2y, which is 8y. Minus 15z minus z, which is 16z. And then minus 6 minus 2, which is minus 8. Okay, so here we end up with this system of equations. Look at this second equation here. Notice z could be anything. So let z be t, and t is a free variable. Let's plug that in for z here. And solve for y. Okay. Let's divide out by 8. And I get y in terms of t. Okay, so we already have z, we have y, and now we want to solve for x. So let's use that first equation here and plug in what we got for y. That was 2t minus 1. Z was t, so let's plug that in here. Okay, and simplify. So we get x plus 2 plus t equals to 2. The 2's cancel out on each side. Subtract t from both sides, we get x equals to minus t. Okay. So x is minus t. Y is 2t minus 1. And z is t. So we have the set of all points like this, where t is any real number. Okay, t is a free variable. So all points of this form are solutions to the original set of equations. Okay, let's do one more example. Okay, let's look at the first two equations. If we take the first equation and subtract the second equation, we can get rid of that x term. So let's do e1 minus e2. Okay, so let's rewrite the first equation. And here we're going to take the first equation and subtract the second equation. So here the x terms cancel, we get y minus y, so that's actually 2y. And then minus z, which is minus 2z. Here we get 0 minus 1, which is negative 1. The third equation stays the same. Okay, now look at the first equation and the third equation. We want to get rid of that x term, so let's multiply the first equation by negative 2. Negative 2 times the first equation, and add that to the third equation. Alright. Okay, so minus 2x plus 2x is 0x. Minus 2y plus y is minus y. Here we'll have 2z minus z, which is just z. 0 plus 0, which is 0. Okay. Let's look at these last two equations here. Let's try to get rid of the y term down here. So let's do the second equation. Okay, that's this here. The second equation plus 2 times the third equation. Okay, just going to rewrite everything here. Okay, for that third equation, we'll have 2y minus 2y, which is 0y. Okay, we'll have minus 2z plus 2z, which is 0z. So everything on the left-hand side is 0. Minus 1 plus 0 is minus 1. Okay, so we get a contradiction here. And since we arrive at a contradiction, we know that the original set of equations has no solution. Okay, no solution.